Hey all, welcome to Homeschool, and this is our sixth video on a chapter Light, Reflection and Refraction. If you want to watch the previous videos, you can just go to the link that is provided in the description, where you will get a detailed explanation on each and every concept. So just in my last video, we discussed about sign conventions for spherical mirrors, right? See, this sign convention is very important. Keeping this sign convention in a mind, we are going to solve certain numericals with the help of mirror formula. Clear? See, what we have to calculate in spherical mirrors is mainly the image distance. Okay, exactly a numerical value. Mathematically, if you have to calculate image distance, then we take the help of this mirror formula and also the sign conventions. Okay, so why we need to mathematically calculate image distance? Ray diagrams are there, isn't it? So when you know the position of the object, you can actually predict the position of image, right, with the help of a ray diagram. But exactly a numerical value, if you want to get, it's not possible from ray diagram. Say for example, imagine this is your concave mirror, okay, and this is the pole, focus point, center of curvature. Okay, say here the focal length is 10 centimeter, you take it. Okay, and imagine the object, I kept it at 25 centimeters distance. Okay, I mean my object is somewhere here. Okay, so this is my object. And where is the image formed? Actually, with the help of a ray diagram, you can able to predict where is image formed, right? So where could my image formed here? Object is behind C, right? So when the object is behind C, definitely the image is formed between F and C. We studied this in ray diagram. Say we can, to some extent, we can predict where is image forming. Image is definitely forming between C and F. But exactly at what centimeter from pole you are getting? Is it at 15 centimeter? You know that, if this is 10 centimeter, if this is 25 centimeter, and this distance, the distance between pole and center of curvature is definitely 20 centimeter. Because focal length is exactly double to the radius, right? Radius is nothing but distance between pole and center of curvature. If focal length is 10 centimeter, this distance is definitely 20 centimeter. So your value is definitely in between 10 and 20. But exactly what is the value? Is it 15 centimeter? Is it a 14 centimeter? Exactly where are you getting your image? That I want. I just don't want the image is between C and F. Okay, image is between C and F, fine. Exactly at what distance the image is forming. This clarification, if you want to know, you have to calculate that mathematically with the help of mirror formula by applying sign convention. Okay, so this is the use of mirror formula, guys. Ray diagrams definitely help where is image forming, but exactly at what position the image is forming is decided only with the help of mirror formula. Okay, so what is this mirror formula? It is the relation between, this is very important, relation between focal length F, object distance U. Object distance can be indicated with U, that we have discussed in the last class, isn't it? And image distance V. Okay, so it is the relationship between focal length, object distance and image distance. The formula is 1 by F is equal to 1 by U plus 1 by V. Very important formula. You should fix this formula in your head and you should never ever forget this. Okay, 1 by f is a focal length, is equal to 1 by u is a object distance, plus 1 by v is a image distance. Okay, and you know the derivation of this formula is not there for 10th level. You would see this in your 12th. Okay, anyway, that is not at all important here, so don't worry about how this formula has come and how it has been derived. Okay, to derive this, lot of mathematics is required, like differentiation and all that mathematical operations you are not studying at this level. Okay, so even if we tell, you will not be understanding the derivation, so don't worry about a derivation, just try to remember the formula here. Okay, say in a question normally focal length will be given, u, that is object distance, will be given. Okay, and v, that is image distance, where is the image formed, at what distance exactly the image formed, you have to calculate. Okay, so f will be given, u will be given, and image distance you have to calculate. Clear? Let us see numericals on this concept. See guys, coming to the first question. See, when you solve any numerical on a spherical mirror, first reading a question properly is important, and later find out what is the given information. And third point is give signs, proper sign for the given information. After giving a proper sign, use the mirror formula and find out what has been asked. Okay, fine. See, find the image distance. So what you have to find? V value you have to find, right? Find the image distance of concave mirror. If an object is kept at 25 centimeter and focal length is 10 centimeter. Okay, so which mirror it is? First identify which mirror it is. So which mirror it is? It is a concave mirror, guys. Okay, if you want, you can first draw a ray diagram and check it out. Predict the answer. Later apply the formula and calculate. You get a numerical value. Okay, but try to predict the answer. Okay. Say for the MCQs and all, this way of drawing ray diagram and predicting an answer will be helpful. But if they have asked for 2 marks or 3 marks, you should use the formula and calculate. But for the MCQ, instead of calculation, when you do a ray diagram, you can able to predict the answer very well. Clear? So I will draw a ray diagram for this. So what they are asking, this is the pole, right? And this is the focal length, and this is my center of curvature. Okay, so what they have given, guys, where did they keep the object? They kept the object at 25 centimeter, focal length is 10 centimeter. Focal length is 10 centimeter. Object has been kept at 25 centimeter. That means somewhere behind C they have kept the object, right? If focal length is 10 centimeter, what is the distance between pole and center of curvature? It will be 20 centimeter, no? Because this distance is exactly equal to this distance. So this distance is 20 centimeter. Okay, so they have kept the object here. So where you have chances of getting image, whenever an object is kept behind C, definitely you will get image, real image. So nature of image you can predict. What is the nature of image? Real inverted image you will get between F and C. Okay, so definitely your value is there between 10 and 20. You will get your value between 10 and 20, right? So now let us apply the formula and calculate. See, this gives a rough visualization of a question. Okay, say if in the MCQ, if your options were like 20 centimeter, 9 centimeter, 16 centimeter and 26 centimeter, definitely what is the option you will select? Your answer, see, image you will get between C and F. Definitely 25 centimeter in the sense object has been, see, object distance. Object distance is 25 centimeter, guys. That means object is kept beyond C. So image you will get between C and F. So according to the given information, if I have to predict, your answer is there between 10 and 20. Right? So between 10 and 20, which value is there here? 16 centimeter. So you can mark for 16 centimeter if it is a MCQ. Okay, so this is how initially putting a ray diagram, visualizing a ray diagram will help in predicting answer for MCQ. Okay, but if you want to give exactly what number you get, you must use the formula. Okay, fine. So let us calculate exactly what value. Now you have an idea. Definitely you get between C and F and it will be an inverted image, right? Okay. So what is our formula? It is 1 by F is equal to 1 by U plus 1 by V, right? This is our formula. But what is a given information, guys? What is a given information? U value they have given, right? So what is U? U is nothing but object distance. So it is 25 centimeter. What is the sign I should give for U? I should give minus sign. This is very, very important, guys, in doing a problem. See, your object is in front of the mirror. So in front of the mirror, whatever distances you measure, you have to put a negative sign. So object distance is always a negative. In question, they won't mention whether it is a positive value or negative value. Okay. Question will be like this. They will say object is placed at this distance. Focal length is this much. You should apply. While applying a formula, taking a sign for U, V and F is very important. If you would have forgot this sign, you will get a 0 mark. You don't get a mark, full mark for this question. Clear? So, see, they just mentioned 25 centimeter, but I have given a negative sign. Why? Object is definitely placed in front of the mirror. In front of the mirror, whatever distances you measure, you should indicate with a negative sign. So, this is where sign convention comes into picture and it plays a very, very important role in solving the numerical. Okay, fine. And now, F value, focal length is given. How much? 10 centimeter. What is the sign you will give for this focal length? Positive sign or negative sign? So in case of concave, where is our focal length coming? Front of the mirror. So all values in front of the mirror has to be taken negative. It's a concave, right? So here F value will also have a negative sign. Say about the sign conventions, if you are not perfect, just go and watch my previous video where I have given clear explanation about sign convention. The link is provided in the description. Okay, fine. So U is minus 25 centimeter, F is minus 10 centimeter. What you have to calculate? V value you have to calculate. So this is the formula. Rearrange the formula. 1 by V is equal to, I can write 1 by F minus 1 by U, right? Substitute the values. What is F? It is minus 10, okay? Minus of 1 by U. U is minus 25, okay? So this implies what is the LCM, guys? So let me take an LCM 250, 10 into 25, okay? In the numerator, what I will get? 10 25s are 250, right? So minus 25. Minus sign is there? No, this minus you shouldn't forget. Minus of, in between minus is there. Minus of and 25 tens are 250, right? So minus sign, don't forget, minus 10. Okay, so how much do you get? Minus 25 minus into minus plus 10 divided by 250, right? So how much do you get here? You will get minus 15 by 250. So your 1 by V is equal to minus 15 by 250. So V is equal to 250 divided by 15, right? Minus 250 divided by 15. So how much do you get here? Ones are, almost you will get 16.6. Okay, so what is your answer? V is equal to minus, you shouldn't forget, minus 16.6 centimeter. Okay, so at what distance you are getting your image, guys? Definitely your answer will be between 10 and 20. But exactly what numerical? At 16.6 centimeter from pole, your image is getting formed. Okay, so V is negative. Image, definitely negative value you got means that image has formed in front of the mirror. So which type of image will be formed in front of a mirror? Real image. Real images are always inverted, right? So if the nature of image has asked, in the question nature they have not asked, just image distance they have asked, but nature of image also they will ask in a question. If nature of image is asked, so what you will tell? The image is real and inverted. Okay, so this much should be your answer. Clear, everybody? So this is the method of solving numerical. So here the three important points what you have to remember: read the question, given information properly you have to write with sign, okay, and formula, then solving, and finally giving conclusion. Okay, so nature of image prediction is also very important. V negative value you have got means the image is formed in front of a mirror. So which images form in front? It's always real. Real images are always inverted. Okay, so this is how you have to do a problem. Coming to a second problem, read out carefully. Reading a question is very, very important initially. An object is placed at a distance of 10 centimeter from a convex mirror. Okay, guys, now it is a convex mirror. It is a convex mirror. In a convex mirror, we all know that focal point and center of curvature is behind the mirror. Okay, so in a convex mirror where they have kept an object is kept here. The distance between the object and pole is 10 centimeters. Okay, fine. Focal length is 15 centimeter. This distance is 15 centimeters, guys. Okay, find the position and nature of image. Find the position and nature of image. Okay, say, can you be able to predict where do you get the image according to the ray diagram? See, here is an object. In case of convex, you have only two cases, right? One is, if you keep your object very far away, that is at infinity, you get your image at focus, right? Another case is, when you keep an object near to the mirror, okay, you get your image between focus point and pole. You get your image between focus point and pole. Okay, say that means your answer is within 15 centimeter. Okay, focal length they have given 15 centimeter. Image you will get between pole and focus. Okay, so your answer will not be above 15. Okay, so definitely your answer is staying in between pole and focal length. That means it's staying within 15 centimeter. Okay, let us calculate exactly. You got a nature of image, right? So definitely image is obtained behind the mirror, in the sense the image is virtual here. Image is virtual. Virtual images are always erect. Okay, and in case of convex mirror, the image is always diminished. That means a very smaller images you will get. Object is bigger, but smaller images you will get, right? So this is nature we got to know. Okay, to find out the nature of image, you don't need to calculate anything. Just by this visualization, you can able to find the nature. But they asked you exactly the position of the image, right? For that, apply mirror formula and calculate. First, Let us note down what is given here. So what is given? U is given, right? So what is U, guys? So where is object placed? Object is placed from 10 centimeters from the pole. Okay, and U value negative or positive? Definitely always U values are negative because objects are always placed in front of the mirror. So this side distances, this is a negative x-axis, right? This side distances are always negative. So U value is always negative. Fine. And here focal length is how much? 15 centimeter. Can you tell me which sign you will give for focal length? Positive sign or negative sign? Definitely focal length is coming behind the mirror. That means it is falling positive x-axis side, right? So focal length value you are considering a positive value. Okay, always focal length in case of concave mirror, since it is falling in front, you are taking focal length negative. In case of convex, focal length always have to be considered positive value. Okay, fine. And now what is the formula? 1 by f is equal to 1 by u plus 1 by v. So they asked you image formation. So 1 by v is equal to 1 by f minus 1 by u. Okay, so 1 by f is 15 centimeter minus of u value is minus 10. So what is LCM here? Let me take 15 into 10, 150. So 150 is the LCM. So here for 15, how much if you multiply you will get 150? 10 if you multiply you will get 150, right? So 10 minus of, and for 10 how much if you multiply you will get 150? 15 if you multiply, say minus is there, so don't forget minus 15, right? So 1 by v is equal to 10 minus into minus plus 10 plus 15 divided by 150. So that will be 25 divided by 150. Okay, so let me write here. So 1 by v is equal to 1 by v is equal to 25 by 150, right? So 25 ones are 25 6 are 150, right? So 1 by v is equal to 1 by 6. So what is v, guys? Your v is equal to 6 centimeters. Clear, everybody? So what is at what distance? I told you, your answer is within 15. So at what distance from a pole you are getting image? Exactly at 6 centimeter distance from the pole you are getting your image. So what's your answer? V is 6 centimeter. What is the nature of image? Virtual, erect and diminished. Okay, so this is how you have to do a problem. Let us see few more questions. Coming to the third problem, people. A convex mirror used for rear view of an automobile has radius 3 meter. See, they have not given focal length here, they have given radius. Okay, let me draw a diagram here. So we have a convex mirror, isn't it? So this is our convex mirror. Fine. And this is a pole. This is our focus point. This is our center of curvature. So what do you mean by radius here? The distance between pole and center of curvature. This distance they have given, that is 3 meters. Okay, fine. If a bus is located at 5 meters, say bus is here. There is a bus here. Okay, this distance is 5 meter. Distance between pole and object. Object is bus here, that is 5 meter from the mirror. Find the position of the image. Where is image formed, guys? So think of whenever an object is near to the mirror, okay, if not infinity, near to the mirror, always image is formed between pole and focus, no? Okay, so that means your value will stay in between pole and focus. Okay, so this is where you get image. What is the nature of image? Definitely, since it's a convex, image is formed behind the mirror. So nature you got to know, it is virtual erect. Okay, virtual and erect image you will get between focus point and pole, but exactly at what number you get a image have to be calculated with the mirror formula. Okay, fine. What is given information here? Okay, say object distance u is given. How much? 5 meter. So it is minus 5 meter you have to take, because object is always front of the mirror. So whichever distances that you measure in front have to be considered as negative value. Okay, fine. And what else is given? Radius is given, guys. Radius is given 3 meter. But for our formula, what we want? What is our formula? 1 by f is equal to 1 by u plus 1 by v. Okay, so v value they are asking. You want focal length, you don't want radius. But how do you calculate focal length from radius? Yes, so what is the formula? F is equal to R by 2, isn't it? Right? So here F is equal to what is R? 3 by 2 meter. Right? And what is the sign of focal length? Focal length is there behind the mirror for convex. So these values are always positive. So F value is plus 3 by 2 meter. Okay, so substitute in a formula. What you want actually? 1 by v. V value we want. So 1 by v is equal to 1 by f minus 1 by u. Right. So f value is 1 by f value is, don't substitute guys, because if you substitute 3 by 2 you get some decimals, right? Say taking LCM with decimals is quite difficult, so keep it as 3 by 2 only. You take the f value as 3 by 2 itself. Okay, minus what is u value? U value is minus 5. So denominator to denominator goes numerator. This I can write 2 by 3 minus 1 by minus 5. Now it's easy to do LCM, right? So 1 by v. 1 by v is equal to, so 3 5s are 15 I will take as LCM. So here how much if you multiply you get 15 for 3. 3 5s are 15, right? So 5. 2 5s are 10. So here 10 minus of, so here 3s are, right? So don't forget this minus sign. So I am taking minus 3 here. Right? Right. So now 1 by v is equal to 10 plus 3. Minus into minus plus 10 plus 3 divided by 15. So 13 by 15 I will get. 1 by v is equal to 13 by 15 I will get. Positive value only I am getting, right? So v is equal to 15 by 13, guys. Okay? So v is equal to 1.15 centimeter. 15 by 13 is 1.15 centimeter. Okay, so this is how you have to calculate. Say 1.15 meters. Sorry, I cannot take centimeter, it is meter, because focal length is given in meter, right? And object distance in meter. So image distance also, it should be there in meter. Okay, say from 1.15 meter from pole you are getting your image, and the image is virtual and direct because positive value. V is positive in the sense definitely it is formed behind the mirror, right? This is where it has formed in the positive x-axis. Okay, say this is how. Carefully you should see what is given, apply the sign convention, then substitute in a formula, calculate. Okay, and this fourth problem is for the homework. Let me read out the question. Focal length of diverging mirror. Yes, diverging mirror in the sense what, guys? Concave or convex? Diverging mirror is nothing but convex mirror. So they have given information of convex mirror. Converging mirror means concave. Diverging mirror in the sense convex. So focal length of some convex mirror is given, that is 15 centimeter. Object is kept at a distance. That means object distance is given 30 centimeter. Find the image distance and its nature. Okay, so do the problem carefully, put the given information along with the sign, apply the formula, calculate, post the answer in the comments. We will be waiting. Okay, let me check out who is giving the first answer for this particular question. Okay, so I complete this session. Let us meet up with the next session. Next session is also relating to this only. We are discussing about the magnification. Okay, by applying mirror formula, you can find out exact position of the image and also nature of the image. But if they are asking about size of the image, okay, size of the image, say image is formed, it will have certain size, smaller than the object or bigger than the object according to the position of object. Okay, so to how much extent the size has decreased or increased in the image comparing to the object, this is what we mean by magnification. Okay, you will not get exactly same size of image, okay, as that of object, right? See, the size definitely varies. Sometimes you get a bigger image, sometimes you will get a smaller image. So if you want to talk about the size of the image comparing with the object, then we need to know a concept called magnification here. Okay, so in my next class, let us talk about magnification and let us see the same kind of problems. Okay, you got to know position and nature. Along with that, if size is also asked, then you must able to use the formula based on magnification also. Okay, so we discuss all of them in my next class. Till then, keep revising the concept and do subscribe our channel to learn the concepts in the easiest way and in a detailed way. Thank you so much.